Hello, in this video we're going to show you how we built our Canadian Canoe Mould for our resin infusion courses using a partly old-fashioned method to create the plug. ECF Composites can trace its history back to the 1960s. Before becoming one of the UK's leading suppliers of composite materials, we were a major manufacturer of GRP products. While looking through our photo archives, we came across images of some of these early mouldings. Here's a newspaper clipping from 1971, when the company was manufacturing police dog kennels for the Durham Police canine unit. The vast majority of contracts at the time were for GRP components used in ocean rescue. We supplied parts to companies such as Ocean Safety and RFD, and we also worked with the US Navy. Before producing any moulds for these parts, we first had to create what's known as a former or a plug. Back then, plugs were typically made from a combination of timber and filler and finished with a polyester primer and then polished. This approach was later replaced by more modern materials and processes, such as polyurethane tooling board and CNC machining. However, both methods were capable of producing high-quality moulds and finished products. In those days, if you wanted to learn how to mould fiberglass, you'd usually have to serve your time in a GRP factory or consult an experienced laminator or hope to find a good book that explained the process. Today, you can simply search online, contact our technical team or browse our YouTube channel. We still have a reference library in one of our offices which includes some very old books. This one, Canoe Craft by Ted Moores, was published in the 1980s and proved to be a useful source of research for building our canoe former. This other publication dates back to the 1960s. If you've been in the industry long enough, you may remember the Strand Guides published by Scott Barder. These are now very rare and no longer printed. Or this one, the new Glassfibre Book by R.H. Waring, first published in 1971 and reprinted throughout the 1970s. It shows many of the old methods used to make plugs and moulds. This book was later updated and republished in the 1980s as the Glassfibre Handbook. It still references techniques that use timber, wire mesh plaster and even cardboard to create formers and plugs. It was this type of framed construction that caught our attention for our most recent project. Since moving away from manufacturing and focusing on composite materials supply, we no longer have access to CNC machinery. So, for our much needed resin infusion course mould, we decided to go old school. This also gave us the chance to use up scrap materials and near end-of-life resins we had in stock. Originally, we didn't plan to film this for YouTube. That's because we're well aware of the issues that can arise when using a mixed range of materials to build a plug, something we wouldn't normally recommend. Differences in expansion and contraction can lead to warping or surface distortion, which may transfer to the finished mould. These issues can often be seen on older GRP car parts that don't fit particularly well or have surface imperfections. That said, this mould isn't intended for high-end production, so these risks weren't a major concern. We decided to document the process anyway, as it might still be interesting to share the results, good or bad, with our viewers. We started by sourcing a technical drawing for a Canadian canoe. From this, we built a strong back and a series of formers to define the canoe's shape. This type of former is commonly used when building cedar strip canoes, but in our case, it served as a guide for shaping the PU foam. We then glued blocks of polyurethane foam into place using a high-quality contact adhesive, filling all of the sections. Using a saw, we roughly carved the foam and then sanded it down to the required shape, regularly checking alignment. A straight edge or steel rule was used to make sure each section flowed smoothly into the next. At this stage, you can see the canoe plug starting to take shape. Unfortunately, our video footage for the next stage was corrupted. However, once we were happy with the shape, we stabilised the foam with a coat of resin and allowed it to cure. We then sheathed the entire surface with fiberglass cloth and epoxy resin and left that to cure. Afterward, we skimmed the surface with a mixture of epoxy and fairing filler. Once cured, it was time for more sanding and final shaping. After all that hard work, we sprayed the plug with Durham Grey Surface Primer, a polyester-based high-build primer. We then mist-coated the entire plug with PVA release agent. You'll also notice that we added a return flange to the mould. This helps the mould retain its shape after release and provides a surface for attaching vacuum bagging materials later on. After the PVA had dried, we applied a light coat of wax and buffed it off with a cotton cloth. While there are more modern release systems available, this method has always proven to be reliable for us over the years. Next came the gel coat. We used a tooling gel coat which is tougher than standard mould gel coats. Because of the large surface area, two people work together, one applying the gel coat and the other spreading and evening it out. This speeds up the process and helps ensure an even finish before the gel coat starts to cure. As a guide, gel coat covers approximately 1.6 square meters per kilogram. Once cured, it's good practice to apply a lightweight layer of reinforcement first, such as 300 gram, 1 ounce chopped strand mat, fully consolidating it to remove any air pockets. This layer is then left to cure. For the remaining layers, we used a tooling resin with 450 gram chopped strand mat. Tooling resins require at least 5 layers to be applied in one session to achieve a proper cure and benefit from their low shrinkage properties. This also allows the mould to be released after 24 to 48 hours for a faster turnaround. If using a general purpose resin, it's best not to exceed 3 layers at a time. Allow them to cure before adding more. In that case, the mould should ideally remain on the plug for at least a week to reduce the risk of shrinkage and distortion. 2 days later, we released the mould from the plug, and to our surprise, it turned out very well. There's a slight waviness to the surface, but it's more than adequate for our needs. After a bit of cleaning and polishing, the mould was almost ready. After applying our release system, we produced a thin, sacrificial skin coat using spare white gel coat and scrap matting. This helps break in the mould and confirms that everything releases cleanly, which is often necessary after initial waxing. Finally, after applying a clear epoxy-compatible gel coat and allowing it to cure, we laid up carbon fibre and carried out a test resin infusion. This allowed us to see how the finished part would look before putting the mould into regular use for our infusion courses. Once again, we were very pleased with the results, especially considering how quickly the mould was produced using a mixed selection of materials for the plug. Thanks for watching today's video. We hope you enjoyed it. If you have any comments, suggestions or questions, please do comment below and we'll get to them as soon as we can. As usual, all materials shown in our videos can be bought from our website at ecfiberglasssupplies.co.uk. Have a good day.